Hi, I'm Clark Richey, Principal Technologist at AWS.
And I'm Laurent Domb, Worldwide Public Sector Chief Technologist for Federal Financial Services, and I'm also running the Worldwide Chaos Engineering practice.
I've asked Laurent to join me here today to help me understand chaos engineering a little bit more deeply, and hopefully it'll help you as well. Thanks for joining me, Laurent.
Thank you, Clark. Happy to be here.
Laurent, I've got to be honest with you, I've always been interested in it, but I've never really done any chaos engineering, or I guess we call it experimenting now. Help me out with that, actually. How should I talk about it? What's the right terminology for me to even use now?
So when we're thinking about chaos engineering, we distinguish between tests and experiments. Tests produce outcomes of the knowns that you know about your systems. When you're thinking about experiments, it's all about the various unknowns within a system that you're trying to discover.
It sounds really interesting, but it feels like a lot of work. Like, what's the simplest way for me to get started if I want to do chaos engineering? I mean, do I have to be a really big company and have a massive production system, or can I start small?
You can absolutely start small. So when you're thinking about chaos engineering, it's important to have basic observability, because when you inject, for example, a fault, you want to understand and see what is happening to your environment. You want to have a sponsor, because chaos engineering, you need to have a team that helps understand the workload itself before you start and build any experiments. And that is critical. Additionally, you want to have real-world scenarios that you can go and execute, and you need a commitment to go and fix, for example, findings that you get out of chaos engineering experiments that you run within your environments.
Okay, so in my team, we do a lot of like unit testing and integration testing and things. And for some of our workloads, we even do some stress testing and some load testing. What kind of value am I going to get from my chaos experiments that I'm not getting in that kind of testing I'm doing already?
So when you're thinking about the traditional tests, it's all about you have an input and you have an output. And with the output, you know exactly in the test what you're expecting. For example, when you're thinking about load testing, you're running the load at 1x, at 1.5x, at 2x, and you see how the application behaves. When you're thinking about chaos engineering, you're injecting, for example, latency into the network. And you increase latency over time to see how your workload and the downstream dependencies start reacting to the fault that you inject, meaning that now, instead of having the known of a test, that you know what the outcome should be, it's an anticipation. We call that a hypothesis in chaos engineering, where you're thinking something may happen with your workload, and you validate or you verify, depending on the end-to-end workflow, it's the verification, if your workload is resilient or not, and if the hypothesis holds true.
Okay, so it's definitely different than those other tests I've been doing where, like you said, I'm validating that it behaves properly and I kind of know what I'm expecting. Here, it sounds like if I do something maybe where I break the networking, for example, between my application and my database, I might think I know what the application is going to do, but maybe I don't really know because it's complicated, right? We haven't really tested that. Is that really the idea that maybe I think it's going to happen one way, but maybe it doesn't, and maybe that's okay, or maybe it's not, I guess, depending on how it fails?
Yeah, I mean, think about if you, for example, look at a payment system and you run transactions, and you may build that payment system for 3,000 transactions a second. With 3,000 transactions per second, it works perfectly fine. With 3,500 transactions per second, it still works perfectly fine. And even if, for example, you inject some faults, like terminating EC2 instances and auto-scaling group would spin them back up. But if we look at the system as a whole, and for example, we look at the application code, we start with the understanding of where circuit breakers, for example, implemented. Do they catch if, for example, a fault happens? Do you suddenly get back pressure within the system or not? Things like that we're trying to understand when we're injecting faults within chaos engineering, so that we can have mitigation mechanisms in place to make sure that if such a fault, for example, happens, that we can mitigate it.
Okay, so it sounds like it really can be an iterative process. Like I may think it's going to happen one way, and then I run the test, and maybe my application behaves a little bit differently, and we go back, we make some changes and some adjustments, and then we can run that test again and again until, I don't want to say we get it right, but until it at least comes out the way we hope it will.
That's right. When you're thinking about the usual game day flow that we run with customers when we're building chaos experiments, the first thing we do is all about understanding the workload. We call that the chaos engineering discovery. Now, when you do that discovery, you're looking at all the aspects that we have in regards to the well-architected framework for resilience, so that we look at, are the best practices implemented? For example, do we have observability in place, as I mentioned before? Are we having, for example, circuit breakers implemented? Are we able to have, or do we have retries, for example, implemented correctly and are not triggering a retry storm? If, for example, we're adding latency and the client disconnects and then all at the same time come back. And then once we understand the system and we, for example, usually what we find is there are some known issues that need to be fixed first before we can move on. From a chaos engineering experiment perspective, the team goes back, fixes these, and if everybody has the same mental map on how the workload works, then we go, for example, into the phase where we build the hypothesis, and then out of the hypothesis creates the experiments that we are then running. And absolutely to your question, when you're thinking about the outcomes, sometimes we get surprises. We call them the unknown unknowns within chaos engineering, where that's the holy grail, you could say, of chaos engineering, if there is an outcome that nobody expected to happen when you're actually injecting that fault.
It requires a lot of infrastructure, it sounds like. I mean, most of my tests right now, when they get fired off when I commit code and it gets approved and goes to my CI or CD pipeline and stuff happens automatically in a development environment, right? Because it's smaller and it doesn't cost as much for us to run. But it feels like here I need an environment that really is sort of the same as production, right? So when I run this in production, I need a whole separate environment, and that sounds expensive.
Yeah, so when you're thinking about the majority of the customers that we're seeing today do not run chaos engineering in production yet. The ones they do, you can think about Netflix, for example, in media and entertainment, or Amazon Prime, for example, as well. But then also we have some customers in the financial industry that also are running chaos engineering experiments in production. Now, when you're thinking about the journey of a company that goes through the iterations of chaos engineering, the lower level environments are also providing you with aspects to execute experiments that mimic production impacts. For example, you can think about the execution to simulate a brownout. If you, for example, have 100 nodes and you have a steady load that you're providing to the 100 nodes and you start removing nodes out of the pool, you automatically get a curve of a brownout that you could achieve, for example, in a testing environment as well. The same with latency and downstream dependencies. You could achieve that too if you're in lower level environments. And many times when we're seeing, for example, customers starting out, they run, for example, high CPU or high memory experiments to understand the nodes itself.
So sounds like I could start out and run some of these experiments, maybe even in my development environment to learn about how the system reacts. And then, as I get maybe a little more mature in my process or have some larger experiments that I want to run, that I could run them in another environment that is close to production, maybe not even the same size, but I can start scaling up. And I guess because I'm doing it in the cloud, I can really turn those systems on essentially just when I need them to save me money, and I don't even have to worry about my production system.
Yeah, when you're thinking about the initial stages when you're building chaos engineering, of course, you want to run controlled and secure experiments. So if you're not familiar with the domain, starting in production can exactly have the counter effect of what you want to do with chaos engineering. So getting comfortable with the tooling, with something like fault injection simulator, understanding the automated rollbacks and stop conditions that we have, and how they kick in based on the alarms, then once you understand how that specific experiment manifests itself end to end, and you're confident that the system now can survive that experiment, you will promote it to a higher level environment.
Okay. You mentioned fault injection simulator a couple of times now, and I'm fairly familiar with it, but I'm not sure that everyone is really familiar with it. Could you tell us a little bit about what fault injection simulator is and how that ties in here?
Absolutely. So fault injection simulator is a chaos engineering service that we have in AWS, and it provides you with the capability to understand how, if a component is impacted within the resilience of the cloud, will, for example, affect your application in the cloud. And so that's very powerful when you're thinking about it, because many of our customers use many of our services, and providing them with the capability of getting an understanding if they impact, for example, EC2, or if they're impacting a Lambda function, or if they're impacting, for example, an API gateway or a load balancer, on how their application will see the fault, but then also will provide them with the capabilities of building mitigation mechanisms so that if that fault truly happens, that they're ready and they have minimal to no customer impact.
So it's great that AWS provides a tool like Fault Injection Simulator to allow me to run these experiments really easily against my AWS infrastructure. But do I have to use Fault Injection Simulator, or can I use a variety of open source tools that I've heard are out there? So does that be just one tool, or can it be many, or what's the approach?
Yeah, that's a good question. So when you're thinking about chaos engineering is not about the tool. It's about the scope and the impact that you can have in regards to the faults that you inject into a workload. Now, what's special about Fault Injection Simulator is that uniquely, because we're AWS, we have the capability of injecting faults into the resilience of the cloud that no other tool can inject the way we do. Now, when you're thinking about the open source community and other tooling, we, for example, also integrate with LitmusChaos and Chaos Mesh. And that's very important because that shows that we understand the domain in regards to providing further faults to customers so that they have a broader understanding and capability on how a fault will impact their systems.
Laura, a second ago there, you mentioned something called, I think, Chaos Mesh and Chaos Litmus. What is that? I'm not familiar with those terms.
Yes, when you're thinking about LitmusChaos and Chaos Mesh, they're both open source projects that drive chaos engineering. Both of them are very broad in regards to the faults as well that you can inject. For example, Chaos Mesh is very focused on containers. Litmus has a little bit of everything. And when you're thinking about both, and when you're looking at Fault Injection Simulator, what's key is that the Fault Injection Simulator team recognize that we want to provide more capabilities to our customers in regards to injecting faults, and is integrating with LitmusChaos and Chaos Mesh to broaden that scope. Now, of course, when you're thinking about Fault Injection Simulator, we have a variety of faults that we can also inject into containers. You can think about adding latency, for example, to pods, or CPU and memory faults, or even I/O. So the comprehensiveness is very important there, and being able to scale the faults and injecting further faults through integrations, as I just mentioned, are very important in the domain.
One of the questions that customers ask me all the time is, do I need to do chaos experiments? Do I need to do chaos engineering? And if so, do I need to do it for like all of my applications, or is it just some of it? Because it does take some time and some expertise and some tooling and some cost, right? Even if I do this scaled approach like you talked about. So how does a customer know when they need to do this?
So when you're thinking about chaos engineering, as I mentioned in the beginning, you will have a sponsor that sponsors that domain within your organization. And so you want to have a good return on investment on what you potentially will find for a workload. Now, the highest impact, of course, is in the most important workloads that you have. So if you have a tier 1 workload with an RTO, let's say, of 15 minutes and an RPO of 0, that's probably something you want to invest chaos engineering in. If you have a workload that needs or has a 12-hour RTO and a 2-hour RPO, then you probably don't want to have a team of 4, 5, 6 investigating in how they can impact the workload, run experiments, and see outcomes.
So you say RPO and RTO, you're talking about our recovery point objective. So how much data I can potentially lose, and recovery time objective, like how long my system can be down before I recover it, right?
Exactly.
Okay, so really, it sounds like I want to focus on really my most important applications and workloads, right? So if it's something that if it goes down for a while, it's not a huge impact to my business, then maybe I don't want to or need to spend the time and the money to do the chaos engineering.
Yeah, that's right.
That makes sense. That's in line with what we tell people on a general basis with resilience, right? I have to ask this, of course, because I think, at least I do, when everyone thinks about chaos experiments, eventually we think about Netflix and the stories of companies doing these big tests. I think you call them game days, in kind of very, I always want to say, exciting ways where maybe they do run them in production. They don't necessarily tell the operations team that we're going to do this. It's almost like a secret kind of thing that happens, and they have a group that's looking to see, does the actual operations team catch it? How do they react? Is that real? I mean, do people actually do that, or is that just like, a myth essentially?
Yeah, what we see in the chaos engineering domain, there are actually two camps. So there is one camp that runs, as I mentioned before, the discovery sessions, understanding how the system works, and then they go inject the fault and they verify end-to-end if the hypothesis holds true. The other camp is exactly what you said, is where operations teams initiate a game day and they say, okay, we're going to run some faults. And what they validate is if the teams, operations teams, observability, engineers, have the playbooks and runbooks in place to either automatically recover from the failure that they're injecting, or being able to react in time to minimize, for example, a customer impact during such experiments.
I have to admit, that sounds both kind of exciting and kind of scary. Like, I kind of want to see it done, but I don't think I want to be on the operations team when it's being done. Because it sounds like it could go wrong, right? Like, what if we really do impact production and bring down the service and our customers are impacted? Are there sort of good mechanisms or standard procedures for preventing that from really going off the rails and like taking my business down?
Absolutely. So when you're thinking about the way and how we're running chaos engineering experiments in AWS, you always think about a control group and an experimental group. Now think about a load balancer, for example. A load balancer has a target group. The target group points to, for example, EC2 instances. Now, if you run a chaos engineering experiments, you will already have a certain amount. For example, you have an EKS cluster that has a load balancer and it points to the nodes or to the service and then to the nodes. And you're going to have a control group where you have another target group that points to the nodes that you want to impact. So when you start with the lower level environments and you run the experiment, the impact that you have even in lower level environments is bound to your experimental group. So you're reducing impact from that perspective quite a bit, and you would do the same when you're thinking about going into production. The same when you think about if you have an API gateway, you would use a different stage. Or if you would use Lambda, you would, for example, have another Lambda version that you're going to impact for the experimental group. So reducing impact is key because, again, what we don't want to do and what you don't see unless you're really advanced is the random termination of resources in production. When you're thinking about Netflix, right, or Prime Video, and you're thinking about the way and how they're looking at systems, because they're using EC2 and they have auto-scaling groups, terminating an instance should do nothing to your service in a production environment randomly. So it's very important to understand what is the risk and the impact if I'm running an experiment. And the way and how we gain confidence for that is if we start in lower level environments and we move up in confidence so that we have observability in place, the mechanisms to recover if necessary, and also the confidence in the tooling itself that it actually can recover.
Great. Hey, well, Laurent, this has been awesome. I really appreciate you coming in and talking to me today. I feel like I know a lot more about chaos experiments than I did in the past, and hopefully you do too. And I provided some links to some resources following this video, so you can go and learn more about chaos engineering as well. Thanks for joining us today.
Thank you.